So let's take a look at what CI looks like for LLMs. So unlike classical ML, here you need specialized infrastructure. The reason being the kind of compute that's required is different. We're talking about GPUs or TPUs. You need access to model registries where the large models are going to get stored and versioned. Artifact stores are probably going to be much larger as well than typical feature stores. So that's a big change. You need the ability to efficiently load checkpoints, which means that that type of the infrastructure should also have access to SSDs, and then the evaluation runners for the model that will need to sample outputs at scale for verification with respect to accuracy, with respect to consistency, hallucinations, etc. So all of this is now part and parcel of the CI cycle. Like earlier, it used to be part of the production cycles where you needed GPUs, where you needed clusters of machines or large stores, etc. But now all of that is now required at the CI stage itself. So that's a significant change. The reproducibility expectations need to be adjusted. So we spoke about it in a couple of different ways already. In classical ML, you retrain a machine learning model. You get to see outputs which are nearly identical. At least it's comparable, and you can say that the accuracy is dropped, accuracy has gone up, false positive rates are higher, whatever, and then you can um, make an optimal decision on whether to choose the new model or go with the existing champion model that you already have. Whereas with LLMs, slight changes in the uh, prompt templating, in the ground truth, in the data sets which are used, or even in small hyperparameter or related changes, can result in significant deviations in the output. So that means that you can't just uh, expect to run a test each time and get the same answer each time. So how do you then mitigate this? Uh, you will have to track randomness, introducing points appropriately. So in those cases, make the random state to be set to a constant value for testing purposes, so that it's always starting off from the same seed. Then you need to be able to track checkpoints. The sensitivity to hyperparameters also need to be there. So make sure that all of those are constant, and at the end of the day, also be willing to accept some bit of tolerance um, in the output variations. Right, some bit of output variation will be there. So you've got to be okay with that. Um, how do you model then the output in the testing? That's something it'll have to be domain specific, right? It'll have to be specific to the kind of problem statement that you are asking. Uh, Prompt engineering is a very significant interface, um, um, because prompts themselves are a significant, are the main interface for LLMs, right? So the prompt engineering interface has to be part and parcel of the CI lifecycle, CI cycle, I should say. So which means that you've got to maintain histories of which prompts have worked well, which prompts have produced the consistent results, which prompts are fake prompts, which prompts are toxic prompts to send, etc. So which means you're treating prompts like code, which means it has to get versioned, it has to get compared with previous editions of fine tuning that you did. So you got to test for prompt syntax correctness. You got to verify the output format consistency based on the prompts that you gave, and then drift detection on the prompts themselves, because you treat it almost like data. So that's a critical, new thing that you'll do in the CI. The fourth thing is artifact management. Here, um, because LLMs produce huge artifacts, which means the fine-tuned models themselves are large, right? You got to have the CI process be integrated with model registries, integrated with cloud repositories where these things are getting stored. It needs to be able to cache these artifacts efficiently for being able to run multiple jobs easily. It can't be looking up from the model artifact each time. And then finally, um, tracking the lineage as part of the CI to the fine-tuned model back to the base model is something that needs to be part and parcel of the CI process. It's not just that fine-tuned model repo that's important. you need to be able to trace it back to the source model which triggered the entire thing, which means where did that model get downloaded from? How did it get set up in the first place? How did that model get produced um, as the starting point for the fine-tuning exercise? All of that lineage also has to be tracked. Moving on to the CD side of it. So for CD, for foundation models, like core software, which is component libraries or common services, foundation models have all these downstream dependencies and various downstream projects which are dependent on it. So the CD should focus on being able to create stable releases which are safety critical, mission critical, with traceability to all downstream usages so that it's governable, right? So the Git flow main branch is potentially a suitable vehicle for model dissemination. For fine-tuned models, on the other hand, because it sits on top of the foundation models, they get released frequently, right? So here the CD should focus on speed and iteration. So exactly like what you would get with conventional software or classical ML, output reliability, and then you've got to have safety, but with faster cycles. You can't have the elaborate safety checkups that foundational models need to have. So here the Git flow release branch is a suitable vehicle, which means you use Git flow techniques adapted to LLMs that we spoke about in the last video, and then use main branch for foundation models, release branch for fine-tuned models, and fine-tuned release branches themselves have some other branches which are ephemeral based on experiments and fine-tuning dataset variations, etc. Once you go through those variations and you are ready to release, you come back to the release and do a merge request or pull request, and then you keep evolving. Okay, one I should say one more pattern that we should start looking at is what happens at the usage side, right? So far you spoke about fine tuning and before that with pre-training. At the usage side, one very interesting, you know, misconception that is there with many people is when an LLM is used because it looks and seems intelligent, as I interact with it, it is learning new things about me and therefore it's constantly updating itself. So that's a misconception. The reason I'm saying it's a misconception is the LLM is actually not updating itself. What is happening is the context window is becoming filled, is becoming filled rather with the new information that you're providing about yourself, or with the new information that you're providing in a in newer interactions, in new sessions. So go back to, for instance, your ChatGPT interactions. Many of you have done it before. You'll see that over a period of time, it learns things about you, and as it learns things about you, it's built up a history about what you are as a person and what your preferences are, what your interests are. So do not mistake that for the LLM having updated itself. It's not learned anything about you per se. It's only figured out a way to summarize things about you and store it in a context window and then retrieve it efficiently as and when your session starts again for the next time. So the misconception is the LLM is updating itself. In fact, it is not. So why can't an LLM update itself then with new data? The new data could be new data that's coming in for fine tuning, new data I'm giving it in the context of an application, um, uh, new information that's available from external sources, etc. Why can't it do it? The main reason is, of course, the LLMs are pre-trained models. They're not online learning models, right? So which means that the weights cannot be updated on the fly. You've got to go through an entire fine-tuning cycle. So with that said, let's dispel this misconception by looking at which types of actions, which types of activities the LLMs can be uh, considered as very good at adapting to with new data. So if you look at pattern recognition as an activity, online operation is absolutely possible, which means um, this falls under the category of activities which are good for taking an LLM, fine-tuned LLM, and giving it using it in a zero-shot manner, which means you're not giving examples, you're just asking it to work in a new pattern recognition context, which it can do, or give it few examples and it can immediately pick up on how to recognize the pattern. That's what we mean by online operation. So the trends can be spotted online and it can be extrapolated from there. Reasoning with examples, I mean, very popular topic, especially after GPT 4.0 released its reasoning capability, DeepSeek released its reasoning capability in competition. So reasoning with examples, absolutely, it's an online operation. You don't need to retrain an LLM. Using few short examples, you can give it the context, and then the LLMs can use that context in coming up with reasoning like humans do. Model training, no. LLMs cannot do this as an online operation. What I mean by model training is, um, um, let's take an entire LLM's fine tuning. You can't just give that fine tuning data as part of a prompt. Firstly, the prompts are not that big, right? Fine tuning data is much bigger. And secondly, you can't just give that data and expect it to adjust the weights in the backend. It wouldn't do that, right? Another way of stating this is, can an LLM do the work of a data scientist, right? For instance, um, let's take a fraud detection problem, right? You're being given the task of building a fraud detection model. The data set is large in size and it's a complex problem. You model it and you come up with a model. The model is good, etc. So the question is, can I feed that data and can I give those constraints about the business, which I have painstakingly gathered as part of my model building, and give this as context to an LLM and ask it to build the fraud detection algorithm. So what will it do? It could build an algorithm by predicting tokens, which means it's providing you code. But can it itself do the prediction? No. It wouldn't itself be the model. It can give you code for it. The code might or might not be wrong, right? You'll have to go through that exercise of figuring that out. But it's not going to change its weights. It's not going to become the model for fraud detection by itself. That's what we mean by model training as an activity. Or to put it in simpler English, will LLM do the job of a data scientist? The short answer is no. Can it predict trends? To a limited extent, right? In as much as the context window allows for it to generalize, it can. Now, can it do parameter updates? It's not definitely not an online operation. Because the weights are frozen, there is no scope for self-improvement. So keep this in mind when you work with LLMs. So how do you augment this limitation, so to speak, of working with newer data? So the way this has evolved, right, in the popular usage of LLMs is using common patterns for data lookup and orchestration. So let's take an example. I want the latest information about all my inventory for specific products in my e-commerce marketplace. I don't feed that to an LLM, right? Let's say I've built an LLM to help with shopping. So shopping agent is the LLM. It's designed to work on a website, interacting with end consumers or shoppers, guiding them in the choice of which product and how much to pay, etc. Let's assume that's the problem. For that shopping agent to have the latest inventory at its fingertips as part of the model itself is going to be a daunting task, because the model itself is going to be released as part of a fine-tuning cycle. It doesn't happen daily, doesn't happen weekly also potentially. But the store inventory keeps changing on a real-time basis because people come and buy new things. So the right approach to do this is using LLM's tooling capability to do a data pipeline integration into the inventory database, right, or to the support database. So this data pipeline integration is a critical facet of the LLM usage, which means if you now look at it from a perspective of versioning, CI/CD, etc., LLM usage is just one facet of your broader software product that you're building, which needs to include data pipeline lookup from a database as well, right? So all of that needs to be part and parcel of your system. The next part is, how do you chunk up prompts and responses? Responses meaning responses from tools, such that it coherently assembles together. So the RAG use case is a good example. So I've got, go back to that insurance policy example. I've got the policy of that insurance company in a document, in a PDF. And that policy, somewhere in that multiple page document, there is a mention that existing diabetes conditions are covered. The question that's being asked now from the agent is, hey, I've been a customer for you, with you for the last 5 years. I got diagnosed with diabetes. Do you cover it? So the answer is actually easily retrievable from that policy document. Whether the LLM will do it successfully or not depends on whether you've got the right chunking in place and you've got access to that policy document or not. So that's an example of a RAG use case, where you've got to go fetch data from a document like that. The document is usually going to be chunked and stored in some kind of a vector database also, potentially. Managing embeddings and features. We spoke about the context of feature store. In that itself, this example came up. Then the next example is, next activity is context assembly. How do you put the context window or context, the query, which is a prompt that's coming in, the instructions that have been given as part of the prompt templates, and the chunks from the RAG or the lookups, all of this has to be put together in order to create that single context using which the prompt will get answered. So that is a critical data engineering step, context engineering step, you can think of it that way. So that's also part and parcel of engineering around the LLM. And last but not the least is anonymization and masking. That's very much required because the prompts can, by mistake, include PII information. Responses can also include it. So based on the context, we'll have to do appropriate level of engineering. So long story short, if you look at the usage of an LLM, it's just like any other API, right? So the fact that it's an LLM is important for few reasons. One, you're not going to get the predictable, consistent, deterministic response all the time. So how do you account for that variation? And you've got these integrations across multiple different data sources or data information providers in a way that's very specific to how LLMs operate, which is chunking, tokenization, assembly, etc., etc. So your CI/CD pipeline will have to factor all of this in when you build an entire product that uses LLMs internally. So DevOps is very much applicable. Okay, let's dive deeper into this customer service agent example. The agent looks to answer clarifications for bank customers in plain English. So the bank customer can come in and ask, hey, I've been charged this fee of 15 rupees last month. Why was that the case? The right answer would be, you use the card for a foreign currency transaction. So the foreign currency markup fee is 15 rupees. Can the agent, which is automated using LLMs, answer that? That's what we'll have to figure out how. So you need to have access to a few different types of information. Firstly, you need the ability for the agent to say, am I talking to the right customer? So I don't want somebody masquerading as me and collecting information about me from the agent because the agent is not authenticating correctly. That would be wrong, right? So authentication has to happen correctly. And then the customer's recent data interactions will have to be fetched. The bank's product information has to be fetched, and then the policies for resolving questions also have to be fetched. So if you then look at the service agent, obviously it needs to understand English. That's part and parcel of how LLMs get built. So you're not doing anything special for that. Foundation models can do it for you. But then the prompts and responses are aided by tools, which are an ID module, an interaction database, and a bank product or service policies data store. The ID module will get exposed as an API. The LLM will need to be able to access that API, right? It needs to know when to use that API for authentication and then proceed. Then it needs to know how to fetch the recent interactions using SQL. So which means the agent is generating the SQL for fetching the data. So which means it needs to know what type of SQL syntax that database is able to support. It can't use Oracle syntax for Postgres. Makes no sense. And then last but not the least, bank product and policy information is in documents, PDFs, Word documents, whatnot. So that needs to be chunked up and ready for retrieval augmented generation or RAG type of retrievals. So you've got to engineer all of this together like a regular software system. Okay, so with that, we've come to the end of this week's discussion on LLMOps, especially as it pertains to versioning, CI/CD in all the three stages: pre-training, fine-tuning, and usage. In next week's discussion, where we'll continue with the topic of LLMs, we'll speak about all the rest of the operational topics regarding uh, deployment, latencies, performance, accuracy, trade-offs, etc., bias, security, governance. Let's move to uh, uh, the hands-on portion for this week in the next video.